Hello everyone, answer this question. We have a cyclic process in this form. It's not the Carnot cycle. This is V naught, 3 V naught, P naught, 2 P naught. For n moles of hydrogen gas, we have this cyclic process. Find out its efficiency. Let's see who can answer this question. Cyclic process, V naught, 3 V naught, P naught, 2 P naught, and it's not a Carnot cycle, remember. What is the efficiency of this particular cyclic process? Let me give you the hint. What is the efficiency? Work divided by positive heat supplied to the system. We are looking for this thing, and if you need in percentage you can multiply with 100, but right now we are interested in this term W upon Q. Work divided by what? Positive heat supplied to the system. Now, how many of you can answer W for this particular process? What is work done by the system for this cyclic process? Good. Work is what? Area. You need to find the area. What is this length? 3 V naught, V naught, 2 V naught. What is this length? 2 V naught, P naught, P naught. So the area is coming what? 2 P naught, V naught. And since it is clockwise, take the work what? Positive. Clockwise, it's a positive work. Now the only thing left is to find Q. Q. Let's see you can find Q. And remember, which Q? Positive heat supplied to the system. Q is not the total heat. Q is that part of the heat which is positive. Look here. A, B, C, D. A, B, C, D. A to B is isobaric thing. Isobaric. For isobaric part, dq is simply what? N Cp dt. N Cp dt. Now this term is positive or negative, that's what you need to decide. B to C, B to C, dq will be n CV dt, corresponding dt. This dt and this dt, they are different. B to C is an isochoric part. For this isochoric part, n CV dt, C to D, dq is n Cp dt, change in temperature for C to D part. Again, it's an isobaric thing, and therefore I can take directly what Cp. And last, for D to A, which is an isochoric thing, dq will be n Cv dt, corresponding change in the temperature. So you need to decide which ones are positive and which ones are negative. The ones which are positive will give you what? Q. Now N, Cp, these things are what? Always positive. So what basically you are looking for is the term dt. I'm giving you another 30 seconds. Try to find which ones are positive, which ones are negative, and then use it and give me an answer. Let's say temperature at D is T or T naught. Now at D, pressure is P naught, volume is V naught, temperature is what? T naught. This is an isochoric thing, D to A. So when you talk about D to A, you're keeping volume constant, use PV equals to nRT. Volume is constant. So if you are going to increase your pressure, your temperature is also going to increase. Pressure from P naught becomes 2 P naught, and therefore temperature will be what? 2 T naught at A. Easy है, बहुत difficult चीज नहीं है. Now A to B. A to B, it's an isobaric thing, and volume becomes what? 3 times A to B. If your pressure is constant and volume becomes 3 times, तो ये आपका temperature भी क्या हो जाएगा? 3 times. यहाँ कितना है? 2T naught. 3 times 6T naught. B to C, volume is what? Constant. Pressure from B to C is becoming half, from 2P naught becoming what? P naught. PV equals to nRT. Volume is constant. Pressure is becoming half. T will also become what? Half. 6T naught. Its half is what? 3T naught. Which you can again verify as you move from C to A. From C to A, your volume is becoming what? 1/3. From 3V naught, it becomes what? V naught. 1/3, and you are keeping your pressure constant. If pressure is constant and volume becomes 1/3, that means temperature also becomes 1/3. 3T naught becomes what? T naught. So we have found temperature at each and every point. Once you find temperature at each and every point, now look at this first thing, N Cp dt, direct integration, because N Cp is constant. So you are finding heat supplied from A to B. QAB and CP AB. What is DT? T final minus T initial. 6 T naught minus 2 T naught. This gives you what? 4 and CP T naught. When you go for B to C final minus initial. Final temperature is what? 3 T naught. Initial temperature is what? 6 T naught. This thing is negative. अपने काम की नहीं है. C to D temperature is decreasing. 3 T naught becomes what? T naught. This is also negative. C to D अपने काम का नहीं है. D to A temperature from T naught becomes 2 T naught, and therefore Q dA is coming and CV directly. T final minus T initial, 2 T naught minus T naught is coming what? T naught. 2T minus this. So this part, this Q is basically what? 4 NCP T naught plus NCV T naught. That means the efficiency term is coming 2 P naught V naught divided by N T naught. Take it common. Multiplied by 4 CP N T naught common CV now wherever you go, your P naught V naught will be what? NR T naught. At D, pressure is what? P naught, volume is what? V naught, temperature is what? T naught, and therefore this 2 P naught V naught will be what? Efficiency 2 P naught V naught is simply 2 NR T naught. P naught V naught NR T naught divided by N T naught 4 CP. What type of gas we have? Diatomic. For diatomic gases, Cp is what? 5 by 2 R. Sorry, 7 R by 2. Plus Cv. For diatomic, Cv is what? 5 R by 2. That means this thing is coming what? R, N, T naught gone. You're left with what? 2 divided by, this is 28 plus 5, 33. 7, 4, 28 plus 5, 33 divided by 2. Which is 4 upon 33. Four upon 33. That's the efficiency of this cyclic process. Do you understand this entire process and the answer 4 upon 33, yes or no? And you can also write that this is a good example for competitive examinations. I mean, the very small chance that it will be asked in NEET. This is basically for JEE and JEE Advanced type of thing. But even if you're not looking for JEE Advanced, JEE, if you're taking bio, somebody else only interested in school examination and all. But the thing is that the way all these things are used, small parts of the whole thing, they are very important. What is the term of efficiency? W upon Q. What is W? Area of the curve. If it's clockwise, take it positive. What is Q in efficiency? The positive heat supplied. These things, these are examples, they give you what? A fast revision of all these things, and therefore it's good. And in the entirety, if you look at the complete part, then definitely you can expect something like this in any good competitive examination. Put on fast. And you can also understand one special thing with the help of this example. Had it been a Carnot cycle, for the Carnot cycle, efficiency is what? 1 minus temperature of sink. What is the temperature of sink? What is the temperature of source? Highest temperature during the process, 6 T naught. That's your source. Lowest temperature, T naught, sink. So what is the highest temperature? 6 T naught. What is the lowest temperature? T naught. So had it been a Carnot cycle, its efficiency would have been 1 minus 1 by 6, which is 5 by 6. This is special about Carnot. If you run the whole process between 6 T naught and T naught, the most efficient cycle is the Carnot one and will give you efficiency of 5 by 6. But this is not a Carnot cycle. Carnot cycle has what? 4 components: isothermal, adiabatic, isothermal and adiabatic. So this is some other cycle and it is not as efficient as the Carnot one. And that's why we study what? Carnot cycle, because it's the most efficient thing. The maximum efficiency which you can obtain is provided you run it accordingly, as I've told you, the way it runs in Carnot. So this is extra information, and this also tells us why we study the Carnot thing. Write down heat transfer. What is heat transfer? You are transferring heat from one place to another, and that is called what? Heat transfer. Now, the way this heat transfer takes place for different types of setup is something we are interested in, and most probably you have a rough idea of the way heat transfer takes place. We'll give it a mathematical shape in 11th. First, write down few elementary things. There are different type of things: solids, liquids, gases, vacuum. So how to transfer heat in all different type of setups? We study first that part in this heat transfer thing. So write down And let me ask you first, most probably you'll be familiar with all these things, at least the name part. What is the process which takes place for heat transfer in solids? Write down that, in liquids and in vacuum. If you have the idea, because it's not something which is very difficult, it's basically coming from 9th and 10th. You should be familiar with these things. And I suppose some of you will be answering this thing. So what are the three different mechanisms which we know of for heat transfer? For solids, for liquids and gases, and for vacuum. Very strange. Nobody has answered anything. Nobody, not a single person. Kuishuni, write down this. In solids, heat transfer takes place with the help of conduction. In fluids, convection, and in vacuum, radiation. Well, nobody could answer this, but just tell me that, have you heard these things before, yes or no? Conduction, convection, radiation, for solids, for fluids, for vacuum, yes or no? Because I am surprised that none of you could answer. Question of general knowledge basically. Now everybody is saying yes. Good. So write down everything. In solids, we'll define these parts in detail. So far you have written what? In solids, with the help of conduction. In fluids, liquid and gases, convection. In vacuum, radiation. What all these three things are, let's note down this first. Write down for conduction. In solids, heat transfer takes place with the help of conduction. In solids, heat transfer takes place with the help of conduction. Conduction is a process in which energy is transferred from one place to another. Energy is transferred from one place to another without effective displacement of medium particles. Without effective displacement of medium particles, with the help of vibrations. So everybody has a rough idea of the way sound wave propagates. Same thing is conduction. What is conduction? You have got several molecules in a solid. These are several molecules present in a solid. So when you transfer heat, what is heat? You now know what heat is. Kinetic energy. And that kinetic energy has what? vibrational part also. So let's talk about that vibrational part as of now. So when you transfer heat to this red molecule, let's say, it oscillates. And when it oscillates, the next molecule which is in contact with the first one, the red one, also starts oscillating. And then this process repeats itself. And what did I tell you? This red marker is not going to change its position. It's not going to move from this position to this position. So there is no effective displacement of medium particles, but this energy is received by the black marker, and then the next particle, and then the next particle, and then the next particle. So that's how energy transfer takes place in solids. Solid means those molecules, they cannot leave their positions, but they can always oscillate about their respective positions. So we say that there is no effective movement, but still energy is getting transferred from one place to another. That's what conduction is. We'll develop a complete mathematical model for conduction. Now, write down convection. In liquids and gases, heat transfer takes place. In liquids and gases, heat transfer takes place mostly with the help of convection. Mostly with the help of convection. In convection, medium particles, the medium which you are heating, in convection, medium particles leave their positions and transfer their energy from one place to another. And transfer their energy from one place to another. What is convection? Understand the whole process. हमने क्या किया? हमने एक पानी को गर्म करना शुरू किया. Liquids की बात कर रहे हैं अपन. That is what convection is. So if you talk about this liquid, and remember I told you that mostly, I'll explain the mostly part also later on. So आपने एक beaker में पानी लिया, उसे गर्म करना शुरू किया. Now what happens when you start giving heat to the water molecules? We have a water molecule, suppose. So initially what happens when you supply heat, this layer is going to receive energy with the help of conduction. The base is going to oscillate, is going to vibrate, and this energy will be received by the lower layer. And once this lower layer receives the energy, what happens? Say, let's talk about these are the two layers initially when no heat was supplied, this and this, and they are occupying this much space. Look at my hands, they are occupying this much space. But as you supply heat, they start oscillating. Now, as they oscillate, what happens? You can see that initially these two layers were occupying this much volume. but now they need this much volume, which results in what? Decrease in the density. पहले लेयर पास पास में थी, अब दूर हो गई हैं. दूर होने का मतलब क्या है? डेंसिटी क्या हो गई है? डिक्रीज. डेंसिटी मीन्स this lower portion, it becomes lighter as compared to the heavier layers on top of this portion. And then gravity will do what? If lower layers, these layers, they are lighter and the top layers, they are heavier, then heavy thing will fall down and the lighter thing is going to move up. Lighter layer is going to move up. Effective displacement takes place. The whole layer moves from this position to the some other position. So you're transferring energy, but in this transfer of energy, whole thing is getting displaced. Whereas in conduction, nothing was leaving its place. It oscillated about its mean position and then it transferred the energy. But over here in convection, whole layer becomes lighter, shifts upwards, and the heavier layer, it shifts what? Downwards. And then when the heavier layer comes down, it receives the heat, starts oscillating, occupies more volume, becomes lighter, goes up, its position then is occupied by the other heavier layer, and then this process repeats itself again and again, and the whole liquid eventually acquires what? Heat. First tell me, do you understand the convection part, yes or no? Do you understand the way convection works? The concept of occupying more volume, becoming lighter and all. Are you comfortable with this, yes or no? So, we'll write everything, but before that, just to develop interest, let me ask you one thing. If I take a liquid in a gravity-free space, so let's say inside a space shuttle, in a space shuttle, gravity is present, gravity of Earth is present, but that gravity of Earth is being used for what? Centripetal force. So if you are using gravity of Earth for centripetal force, then all those astronauts, they feel what? Weightlessness. It's not that gravity is not present. Remember, we have discussed this thing in gravitation. Gravity is present, but that gravity is being used for what? Centripetal force. The whole thing is moving in a circle. So if you take the beaker and the heater, all these things to a space shuttle, then is this convection process going to work? Yes or no? What do you think? If I take this thing to a place where there is no effective gravity, then the question is that can I supply heat to this particular setup, to this beaker, water inside the beaker with the help of convection? Yes or no? Good. No, we cannot. Why? Everything is going to take place exactly in the same manner. The moment you supply heat, the lower layer, its density is going to decrease. Its density is going to decrease, but it is not going to become lighter. What? Density is decreasing, but it is not becoming lighter. क्योंकि heavy and light का मतलब क्या है? Weight. और weight के लिए क्या चाहिए? G. तो यहाँ पर if you are inside a space shuttle, there is no G. That means there is no feeling of weight. आप अपने सिर पर एक हाथी को बैठा सकते हो, weight का concept ही नहीं है. तो this thing, its density decreases, but it doesn't become lighter or heavier because that concept itself is not present. तो जब ऊपर हैवी नहीं है, नीचे कुछ लाइट नहीं है, तो फिर कोई मूवमेंट ही नहीं है, एंड देयरफॉर ओनली conduction will work. These molecules are going to oscillate and then will transfer the energy to this layer, which will transfer its energy to this layer, and so on. So we can always frame a question that if you need to supply heat to a liquid in a gravity-free region, then what should be the process? What is the process through which this takes place? And the answer is that it's not the convection, but is what? Conduction. And therefore, in the statement we wrote mostly on earth gravity is present. What is the process working? Convection. But partially this conduction is also present. In a gravity free space, convection is gone, only conduction is present. Write down the whole thing for convection. In convection, when heat is supplied to a liquid, in convection, liquid or gases, in convection, when heat is supplied to a fluid, layer which is in contact with the heat source, layer which is in contact with the heat source initially receives energy with the help of conduction, initially receives energy with the help of conduction, and molecules present in it start vibrating. Thus occupying more volume. Which results in the lowering of density. Which results in the lowering of density. That is, this layer becomes lighter. That is, this layer becomes lighter. And it rises up and its position is occupied by the heavier layers present on top of it. Its position is occupied by the heavier layers which are present on top of it. And this process repeats itself again and again. And this process then repeats itself again and again. We can see that in convection, effective displacement of medium particles takes place. Now, as a separate note, write down this. In a gravity-free space, or a place where effective gravity is zero, I use the term effective gravity because gravity is present in the space shuttle, but effectively there is no feeling of weight, there is no feeling of G, because all that force of mg is being utilized for what? Centripetal thing. And that's therefore I said effective gravity. And if you move at a distance of infinity from any body, gravity itself is what? Zero. So in a gravity free space or a place where effective gravity is what? Zero. For effective gravity, let me tell you, you don't have to go to that space shuttle thing and all. You can create a condition of gravity free thing on Earth itself. Who can tell me how can we create a very easy example? Who can give me that? How can I create a situation where effective gravity will be zero and the process will be conduction only? Have you got any idea how to create a gravity free thing? It's a very easy thing. Look here, look, how can we create a gravity free thing? And don't try this with your body and all. If I drop this marker, then during the fall, it is in gravity free type of thing. Take this beaker, fill the whole thing with water, drop it along with the heater. During the fall, that force of mg which creates what? Heavy and light type of thing is utilized for downward motion. V equals u plus at. It is providing you what? Acceleration. And therefore all these things, they are basically what? In a weightless type of condition. And if everything is in a weightless type of condition, that means during the fall, howsoever little that is, it will take 5 seconds, 6 seconds if you drop it from a very high-rise building. So suppose it falls for 10 seconds, then for that 10-second time, you will be seeing only conduction. There will be no convection. So when you drop things, that G is present, but effectively the whole body is in a weightless type of thing. If you remember in fluids, we had created a question like this, that an object is floating and then the whole beaker is dropped. What is the force of upthrust? The answer is that zero. That upthrust also disappears because of the disappearance of effective G. So in the note part, you can write this, that in a place where there is no gravity or effective gravity is zero, even in a liquid, heat transfer will take place with the help of conduction. As in a gravity free space, there is no feeling of weight. There is nothing like weight, there is nothing like lighter or heavier type of thing. Well, are you comfortable with this gravity free part? In gravity free thing, there is no lightweight, there is no heavy things, and therefore heat transfer will take place with the help of conduction. So do you understand this part for liquids? Yes or no first? Good. Write down the last part, radiation. What is radiation? Everybody knows that energy is coming from sun to earth, but there is no medium present between sun and earth. So no conduction can take place, no convection can take place, but still we are getting energy from sun. That process is what? Radiation. Write down this. Radiation requires no medium for heat transfer. Energy can be transferred from one place to another with the help of electromagnetic waves. Light, it's an electromagnetic wave. X-ray, it's an electromagnetic wave. Radio waves, they are electromagnetic waves. They all are what? Transferring energy. Energy is transferred with the help of electromagnetic waves and these waves can easily travel in vacuum. And these waves can easily travel in vacuum. I will be defining mathematical things for conduction and radiation thing. Let's start with conduction. We have a rod and once we develop the whole thing, you will realize that something similar to this you have already done in 10th class. So this is a rod, a cylindrical rod of length L and cross-sectional area A. This cross-sectional area is what? A. This end is at temperature T1 and this end is at temperature T2. T1 is greater than T2. If T1 is greater than T2, then इतना हर आदमी को समझ में आएगा that heat is going to flow in this direction from high temperature to low temperature. This arrow, it shows you what? Heat flow. The arrow, it gives you the direction of what? Heat flow. Now, we found that if you look at any given cross section, through that given cross section, dq amount of heat, this is the entire rod, and you have taken any arbitrary cross section of it, and through that cross section, what you found that dq amount of heat is flowing in time interval dt. So write down all these terms. dq heat is flowing through the cross section in dt time. Then we define a term, heat current. I. And this heat current I is dq divided by dt, rate of flow of heat through any cross section in time interval dt. You found that dq heat is flowing. I is rate of flow of heat dq by dt. Then it is observed that I is proportional to T1 minus T2, the temperature difference. It is found that this I is also proportional to cross-sectional area A and is inversely proportional to L. लॉजिकल चीज है, आप भी यही ऑब्जर्व करते कि भाई अगर आप T1 माइनस T2 इस टेम्परेचर डिफरेंस को ज्यादा कर दोगे, अगर ज्यादा डिफरेंस क्रिएट करोगे तो ज्यादा हीट ट्रांसफर होगी, देख रहा है। अगर आप ज्यादा एरिया दोगे तो ज्यादा हीट जाएगी, दिख रहा है। अगर आप डिस्टेंस बढ़ा दोगे दोनों एंड्स के बीच का, या क्रिएटिंग मोर डिफिकल्टी and therefore inversely proportional. All things together, you say that I is proportional to what? T1 minus T2 into A divided by L. When we remove proportionality sign, we use a constant. This constant is K. What is K? I'll tell you later. So this whole thing is K T1 minus T2 into A divided by L. Now before I explain other things, let me ask you a simple question. Have you ever seen something similar to this in 10th? And if yes, then where? Have you seen a similar concept? Note down this much and think about it and write down in the comment box. अभी के लिए इतनी सारी चीजें नोट करो and then we'll write a few points. Only one person says yes, they have seen this thing. Let me represent the whole thing in this form and then maybe everybody will say that yes, they have seen this thing. T1 minus T2 whole divided by T1 minus T2 whole thing divided by L upon A upon K. Transfer A and K in the denominator. This K has a name. It's called thermal conductivity. Well, the hint is present over here. Have you seen something like this? Now tell me in 10th, yes or no. When I readjust the whole thing in this form, and it is similar to something which you have already seen. If you feel comfortable with this, if you have seen something like this, the moment you realize it, write down yes in the comment box. Only a few years. Now tell me, have you seen this? क्या आपने ये चीज देखी है? I equals to V upon R. पूछने की जरूरत नहीं, देखा ही होगा यार. This is what? Ohm's law. What is Ohm's law? Hopefully ये देखा होगा. V1 minus V2. What is V? Potential difference. V1 minus V2. और अगर इस R का आइडिया है आपको तो this was rho L upon A, where rho was called resistivity. This rho was called resistivity, which is 1 upon sigma. Sigma is called conductivity. Resistivity, reciprocal is what? Conductivity. Rho appears over here, resistivity. Denominator, conductivity. And everything was present in the very first line. Current. What is I in Ohm's law? Rate of flow of charge. So if I represent I, if I want to represent I, then I will be using dq by dt. शायद सुना होगा आपने, चार्ज को अपन नॉर्मली स्मॉल q से रिप्रेजेंट करते हैं. Rate of flow of electrical charge gives you what? Electric current, which is proportional to potential difference, proportional to A, inversely proportional to L. Rate of flow of heat current, Q, but capital Q for heat. Rate of flow of heat current, rate of flow of heat is heat current. Rate of flow of charge is charge current. Electric current. Now, क्यों मैंने ये लिंक डेवलप करवाने की कोशिश की है? Now for you, nothing is new in this. Everything which you have done in 10th, things like series combination, parallel combination, वो सारी की सारी चीजें आप यहां भी करोगे. So, ये सब बताने का मतलब ये नहीं था कि आपको कुछ डराना है, नहीं. You will feel comfortable because this is nothing special. The only change we have introduced over here is what? In current and all, we normally use resistivity. But over here, we prefer K, which is called what? Thermal conductivity. As a side note, do note down everything, this Ohm's law thing. And then we'll write few things. Well, those of you who didn't write anything in the comment box, now, क्या आपने ये चीज देखी है भाई? ये सब सुना है कि नहीं? Because I will be using the concept of series and parallel first. So tell me first that have you seen Ohm's law, V1 minus V2, L upon A, which is called resistance? If you have not, no issue, I'll explain everything, but it will save me a lot of time if you say yes that you have seen things like these. और कुछ बहुत ज़्यादा नहीं होगा. Write down few points. At steady state, what is steady state? I'll explain that also. At steady state, heat flow through any cross section in time interval dt is dq at steady state. What is steady state? इसको जरा देखना. आई होप ये नोट किया होगा आपने. Suppose you have a rod and its temperature is 20. Let's say room temperature is 20 and therefore this rod is also at what temperature? 20. This end, suppose you maintain this end at 100 degrees Celsius, steam. This end you put it inside an ice box, 0. At this moment, this mathematical model doesn't work. We don't have any steady state right now. What is steady state? This is 100. The whole rod initially was at 20. तो होगा क्या? 100 से कंडक्शन के थ्रू हीट ट्रांसफर होगी. जो 100 के पास वाले मॉलिक्यूल्स हैं वो ज्यादा तेजी से वाइब्रेट करेंगे, ज्यादा एनर्जी, ज्यादा टेम्परेचर. जो 0 के पास होंगे वो स्लो वाइब्रेट करेंगे. पहले ज्यादा कर रहे थे. The molecules which are closer to this ice box end, they were moving faster and they have been placed close to something, let's say, which is not oscillating. Although 0 doesn't mean that things are not oscillating, but for the time being, कि भाई ये चीज oscillate नहीं कर रही है. If it is not moving and a ball comes and hits, तो आपको पता है क्या होता है ऐसे केस में. अगर ये मूव नहीं कर रहा है, ये आएगा, ये हिट करेगा, तो in collision you have seen that this thing is going to move and this thing will stop. So molecules over here, they are going to slow down. यहाँ कहानी क्या है? This end is 100, moving. All the molecules in that steam box, they are moving rapidly, and the molecules that are in contact with that steam box of the rod, they are moving slowly. Now 20 is slowly over here. ये ज्यादा एनर्जी वाले कम एनर्जी वालों के कांटेक्ट में आएंगे, ज्यादा एनर्जी वाला कम एनर्जी वाले के कांटेक्ट में आएगा. देन ये वाले मॉलिक्यूल्स भी क्या करेंगे? फास्ट ऑसिलेट करेंगे. So a time comes which is called steady state. This is the initial setup. When you develop steady state, कुछ ऐसा होगा. एक रफ आइडिया. This is at 100. This is at 0. This cross section is at 90. This one is at 80. Closer to 0, 10. लोगों ने अपनी अपनी टेम्परेचर क्या कर लिए हैं? सेट कर लिए. 100 से जो पास में होगा 99, 98, 97, 96, 95 and so on. 0 के पास वाले हैं 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once everything has acquired its appropriate final temperature, then that time is called what? Steady state. Now at steady state, something special happens. What is that? Which is also why I talked about this Ohm's law. और इससे आपको मजा भी आए और आप लिंक भी कर पाए. Can I ask you a simple thing? What was special in series combination of resistors? Is there anyone who can answer this part? We used to have resistors connected in series, in parallel. In series, we say that something is. So can you tell me what is special about series? If you remember that, If you do not, don't worry. In 12th, you will be taught all those things. But I'm asking you something which is very easy. और हम यहाँ यूज भी करेंगे उसको. लो, हम बोला करते थे सीरीज कॉम्बिनेशन में करंट सेम होता है, पैरेलल कॉम्बिनेशन में वोल्टेज पोटेंशियल डिफरेंस सेम होता है. इफ यू रिमेंबर, इन सीरीज क्या सेम होता है? करंट. लुक एट दिस, all these kind of slices of the rod, they are connected in series, one after the other. So यहां से कुछ हीट ट्रांसफर की, let's say 35 joules per second. सुनना, 35 joules per second. कब? इस स्टेज में नहीं, over here, steady state. When this 35 joules per second is transferred from this point, every cross section has acquired its temperature, whatever it wants to have. Suppose let's talk about the cross section whose temperature is 90. The cross section whose temperature is 90, it receives 35 joules per second. But if any part of this 35 joules per second is kept by this, then its temperature will increase. So what it does, it lets this 35 joules per second pass through it without absorbing any of it. The next cross section, let's say 80, the cross section which is at 80 at steady state, when it gets this 35 joules per second, this 35 joules per second is again received and let go. They never absorb any of it when things are at steady state. At this stage, your I, if you remember series combination, it was shown like this, and we used to say that current is same. So what happens? Electrons are moving, well, in this direction, but for the time being, electrons are moving. No resistor accumulates these electrons. ऐसा नहीं होता कि 20 चले, उसमें से 2 इसने रख लिए. Now 18 are left. इसने 3 रख लिए. 15 are left. No. Electrons are simply moving without being absorbed. Steady state, all that heat is moving through different cross sections without getting absorbed. Not in this condition. अभी क्या हो रहा था? Initial condition में ये 100 है. The very first moment you bring the rod and put this hand inside the steam box, यहाँ से अगर 35 चला होता, तो part of that 35 joules will be absorbed by this cross section, so that its temperature increases from 20 and becomes what? 99. So at that point, we do not use this. Only when things are at steady state, we'll be using and say that this thermal current or heat current dq by dt through each and every cross section is same, which is similar to this. Now tell me fast before we continue further, are you comfortable with the concept of steady state? Nobody is going to ask you this. We are interested in this, but conceptually पता होना चाहिए. Are you comfortable with the concept of steady state, heat being same because of this, and the similarity with R? Yes or no first? Good. I forgot अपन कहाँ थे, and therefore write down these points again. maybe कुछ repetition दिख जाए, but since I forgot कि अपन कहाँ चल रहे थे. At steady state, every cross section, I'll just take 2 minutes more. At steady state, every cross section acquires its temperature depending on its distance from T1 and T2 ends. Where you are at closer to T1 or closer to T2, depending on that, it acquires a temperature. And then when some heat passes through this cross section, no part of it is absorbed, and therefore heat current dQ by dt through each and every cross section is same. Equation number 1, let's call it equation number 1. Equation number 1 is only used when system is in steady state. When system is in steady state. Last 1 second, 5 seconds, think fast. This is I. T1 minus T2. Let's call it delta T. You can always call this V delta V. Potential difference divided by R. Which R? We'll call it R thermal. So that everything is what in this format. What is I? Thermal current, heat current, temperature difference, potential difference. R thermal, R electrical. What is R thermal? R thermal is what? L upon K, where K is what? Thermal conductivity. K is what? Thermal conductivity. And we will discuss about R and thermal conductivity and things like these in the next class. Hopefully you understood every part of this lecture. Note down everything and then you can leave. Thank you very much.